Hey, it's Justin from Space Science, and today we're going to talk about the solar system. Our solar system is estimated to have first begun forming 4.6 billion years ago as a molecular hydrogen gas cloud, slowly condensing as gravity pulled itself together. When the center gets massive enough, it collapses on itself, forming the star. This is known as the Nebular Hypothesis. During this process, an accretion disk is formed where the gas orbiting the star forms a disk-like layer. Over millions of years, the densities of different elements and compounds start to separate, with the denser elements staying closer to the star and the lighter elements expanding out. This can be seen when looking at the density of planets today, with the inner planets more dense than the outer planets. Planets start to form with the clumping together of masses in these clouds, accumulating over time and growing in size by pulling more matter together. Eventually, the orbital lanes became cleared out and the large bodies that we had left over are what we call planets. Sometimes the regions aren't always cleared out and there are what we call small planetesimals left. This is evident when we look at the Asteroid Belt and the Kuiper Belt, which are made of small bodies from the formation of the solar system. Moving forward to our current solar system from the center outwards, we have the Sun, the inner planets, the Asteroid Belt, the outer planets, the Kuiper Belt, and the Oort cloud. At the center of our solar system, we have the Sun, a G-type main sequence star, or commonly called yellow dwarf. At 1.9 times 10 to the 30 kilograms, the Sun has 99.86% of the mass of the entire solar system. The Sun provides light and energy to the entire solar system, fusing helium into hydrogen through a process known as nuclear fusion. As we move on, we have the inner planets, in order from Mercury, Venus, Earth, and Mars. Also known as terrestrial planets, they are made up of silica rocks and metals, having a metallic core with a silica mantle. The asteroid belt, which lies in the space between Mars and Jupiter, is made up of millions of asteroids varying in size from microscopic to hundreds of kilometers wide. Although there are millions of asteroids, the volume of space that they occupy is huge, leaving large gaps of empty space. So far, not a single spacecraft sent through the asteroid belt has been hit by an asteroid, and these spacecraft are flying at thousands of kilometers per hour. Beyond the asteroid belt are the outer planets, or gas giants, starting with Jupiter, Saturn, Uranus, and Neptune. Gas giants don't have a surface like the inner planets, but instead are layered with hydrogen and helium atmospheres. All the outer planets are known for their ring systems, although Saturn has the most dazzling display of them all. Next up is the Kuiper Belt, which lies between 30 and 50 atomic units from the Sun. Very similar to the asteroid belt, except instead of containing rocky planetesimals, they are mostly made up of ice. Many short-period comets are also believed to originate from the Kuiper Belt. Long-period comets, however, are believed to originate from the Oort cloud. The Oort cloud, extending from 50,000 to 100,000 atomic units, is a hypothetical cloud of trillions of icy objects. We know very little about the Oort cloud due to the small size of the objects and their extreme distance from the Sun. As small non-light emitting objects, their discovery is very difficult, besides studying comets with orbits calculated to reach the Oort cloud. I hope you enjoyed this video of space science. Don't forget to like, comment, and subscribe for more.